After the launch of the James Webb Telescope, it rapidly spread throughout the world after publishing its first Webb images in July of the previous year. The most impressive space telescope has ever shown its specialized power in the form of pictures, and right now our new eye into space that takes awesome pictures is extremely impressive. We might want to think back with you today at some exceptional Webb achievements of the previous weeks, which have left about 2 specialists and all of us intrigued by its recent most amazing investigation in space. Ambitions and objectives. So when the $10 billion James Webb Telescope went into space on December 25, 2021, it wasn't alone. The hopes of all the scientists in the world were also on board. For Webb's mission to reach these lofty goals, scientists expect nothing less than a complete change in how we think about the universe. Scientists expect it to give them the kind of pictures that no other telescope has ever managed to. 4 major scientific tasks have been assigned to Webb. First and foremost is the search for the first luminous objects and galaxies born after the Big Bang and during the so-called Dark Ages. The second is that the structure-forming processes of the cosmos are expected to be understood more precisely than ever before. The third one is the analysis of the formation and development mechanisms of galaxies, black holes, and the like is one of the exciting fields of research to which Webb devotes itself as part of its assignment. Last but not least, the experts hope to get closer to answering one of the most fundamental questions in human history. Are we alone in the universe? Or are there any other beings called aliens? Webb will study exoplanets, analyze their atmospheres, and make guesses about whether or not they could be habitable in order to understand the telescope's power. Which is often talked about, it's important to think about the example that we'll give you. From the Earth, for example, Webb might be able to pick up the heat of a bumblebee on the surface of the moon if it was made with infrared astronomy in mind. The amazing machine can pick up electromagnetic waves up to 100 times better than Hubble. Webb's unmatched technical precision can let us see into even previously unexplored interiors of stellar events. This, in turn, helps us find out more about the chemical makeup of exoplanet atmospheres better than ever before. One unique Webb image called Protostar in Dark Cloud 1527 was just posted recently and shows how amazing it can be to look into the universe without encryption. Let's take a closer look at the bright growth of the new celestial body. Stars are basically made when a cloud of dust and gas in space collapses under the weight of its own gravity. It's in the center of a structure that looks like an hourglass, and a rotating accretion disk is all around it. Because of this, the center's matter gets so dense that molecular hydrogen breaks apart into atoms. This causes protostars to form, but even though they already shine brightly, they don't have enough matter to start nuclear fusion. The baby star doesn't start to condense to the point where fusion starts and it becomes a full-fledged star until it's eaten itself big and strong, which happens about 450 light-years away in the Taurus molecular cloud. Based on what we know now, big gas planets like Jupiter can form when a star is only 100,000 years old. This is true as long as there's enough material in the accretion disk around the new star for planets to form. After the planet's stony heart has formed, this is usually true for all radiating celestial bodies with at least one solar mass. Even though it starts to bind the gas around it to itself, scientists have been able to find gas planets in the realms of much less mass. Given the lack of material and the short life of the accretion disk in an environment with a lot of ultraviolet light, it's still not clear how planets could even form. This already strange situation is turned on its head by the recent discovery of the exoplanet TOI 3757b. It has a density of only 0.27 grams per cubic centimeter, which makes it look very fluffy. Unofficially, it's called a marshmallow planet. Since even water is 4 times denser than Marshmallow World, the planet could theoretically float in a swimming pool. It's about 580 light-years away from Earth and is about 90,000 miles across. It's about the same size as Jupiter, but only 25% as heavy. Experts have no idea how exoplanets came to be, but how can the nature of the marshmallow planet be explained if the heat flows haven't changed much? In this case, the usual explanation, which is based on how much heat a celestial body gets from its host star, doesn't work. Scientists talk about two possible reasons for this: a lack of metals and the effect of tides. Because the red dwarf and its companion planet have only 1/3 as many heavy elements as similar constellations, the original accretion disk may have had much less material for planet formation. But because the exoplanet's orbit around its central star is a little bit wavy, it's possible that the tides pulling on it are as well. Experts are once again hoping to use the James Webb Telescope, and a thorough investigation should help solve the fluffy planet mystery. The pillars of creation are wild, majestic, and powerful. With the James Webb Telescope, we can now look at the Eagle Nebula and be amazed at how it's made. The colossal pillars of creation can be explained in many different ways. It's not a coincidence that the 7,000 light-year away formations, which are the result of something called photoevaporation, are actually called creation. If you compare the Webb image to those taken by Hubble before it, you can see right away how many details we've missed in the past. Areas with the most dust show up as rich, dark grains. At the tips of the columns, dust and molecular hydrogen come together to form bubble-like bulges. This is where new protostars are born from then on. Because of the reddish glow near the top of the photo, the dust here looks much cooler and less dense. When Wolf-Rayetars are about to leave the cosmic stage, they give one last parting detail that is both fun and exciting. The purple spheres that were sleeping at the edges of the columns turned out to be those young stars that were still wrapped in a thick layer of dust. Older stars that had already gotten rid of most of their dusty cocoons gave off a blue glow. We're dealing with the exposed centers of celestial bodies that used to be very big but are now in their last stages of life. At this part of the process, WR stars send out huge amounts of gas into space through what are called stellar winds. In the same moment, the celestial body loses almost all of its shell and gets very hot. When the surface of a star gets to be tens of thousands of degrees Fahrenheit, it shines with a light that's incredibly bright. Here is the fact that the celestial body is not alone. Instead, it's part of a double system with a large blue supergiant. The orbit of the stellar duo is set up so that every 8 years, the two celestial bodies come very close to each other. This rendezvous of the stars is accompanied by a very powerful show. When the stellar winds of the two celestial bodies collide, the gas that's being carried along compresses with an intensity that can't be matched, and this interaction causes heavier parts, like stars, to break off. In an image that had never been seen before, Webb's Happy Spectrometer shows us the features that form during the process and look like the yearly rings of stars. On the Webb image, however, we can see 17 of these interesting structures, while older telescopes could only see a maximum of 2. MIRI's data also showed that the dusty rings move through space at a speed of nearly 1,500 miles per hour. Experts' WR-140 is like an astrophysical laboratory. When we figure out how it works, we'll learn more about how dust is made and how particles stay together in places with a lot of radiation. That was all from this video. Thank you so much for watching this video, and stay tuned for more interesting content.